machine team. And one of the first things we ask ourselves is, what is green? Green is, first off, being from Green River Community College, green is the color of our school spirit. Green is also the color of grass, but more importantly, green is commonly associated with environmental friendly activities such as driving a hybrid car, wind and solar energy, and recycling. On this note, the HPPV competition promotes students to make environmentally friendly transportation vehicles. And with this idea in mind, we decided to make a green bike. Green in the sense of environmentally friendly, and green in the sense of school spirit. And this is how we came up with Brutus. Brutus is primarily made out of recycled paper. We will be describing the design process and the construction of Brutus. But let me first introduce the construction team. First, we have Justin Larson, the leader in the organization. We have David, SolidWorks man. Next, we have me, Josh, the lackey, and Chrissy, the chick. And now I'll sort of hand it off to Justin to talk about the design.
So for our design, the first thing we needed to look at is what we were going to be doing. And this is a competition, it's a race, it's time. We wanted to try to set a new lap record this year. That's kind of our goal. And we wanted to do it on something that would be capable of easily completing the course. Last year we built a bike and it did great. It was a tank, it was super strong. We crashed and it survived, we finished the race, but it was hard to ride and it crashed and we didn't want that again. So this year we focused on adding some features to make it easier to ride. We scaled it down, we made it a little bit smaller. We wanted it to be lighter, we wanted it to be nimble. And we added a suspension fork using air bladders, a ratcheting drive system, and a disc brake. So these all made it much easier to ride. So the first thing we had to do is we had to sketch out our basic design. We took some design cues from the Ibis Mojo, which is a mountain bike, and we sketched out how we wanted it to look and what features we wanted to incorporate. Then we went to SolidWorks. We completely modeled it in 3D before we started doing any building whatsoever. We needed to integrate everything so it would all fit, it would all work, and so that our build would go smoothly. So with that done, with our basic design in place, it was time to do some testing. Next slide. We wanted to make sure that we could keep it lightweight and yet strong enough so that we didn't have to worry about failures. We used Simulation Express in SolidWorks to analyze our design. I did some dynamic loading calculations and plugged the numbers in based on the absolute maximum possible stresses. We were shooting for a factor of safety of about 2, and we succeeded in that for the most part. Our wheel, when we loaded it sideways, like during cornering forces, had a factor of safety of about 1.8, but we were comfortable with that because that was, again, our maximum possible loading that we could figure it would ever have. So once we had all our components designed and ready to go, I should also mention that we designed a custom gear train. Our gears were machined by our machine shop, and David's going to explain that process for us.
As you heard, we had a complete custom drivetrain. Every single one of our metal parts is completely custom designed except for our cranks. We did this because we wanted to minimize weight and maximize strength. So this was the funnest part for me. We got to take all our drawings over there, we got over there, and we had some square holes we wanted them to make. And they said, nah, we can't make square holes. So we had this kind of back and forth process for a whole week of, here's our goals, and then here's what they can make, and then when those points cross, we had the sweet spot. So we have a custom machine, 70 series, 32 tooth front chainring, and we have a steel 15 tooth rear chainring that they machined on our 3-axis mills. They actually did it as an educational thing. We brought them their 2D designs, and then they got because they're training in Mastercam, they drew it all in Mastercam, so they got practice in that. And we have a 60,000 series drag plate, and then the cool thing with our drive plate and ratchet assembly is we had to ratchet, and we were able to integrate our drive plate because the ratchet has extrusions off, and we matched the extrusions into our drive plate so it completely transfers the load. We did the same thing for our steel rear chainring. We integrated the 6 holes in it so we can bolt it together and get complete power transfer. Next slide. That was just all the stuff we had machined. After we had it machined, we went over to our weld shop and they TIG welded our drive plate onto our rear axle and our 32 tooth chainring onto our bottom bracket. And then we have as you heard earlier, we have a mechanical disc brake. We had to actually cut this down a little bit because we were really worried about our non-paperweight, because as you can see, we have a lot of metal stuff going on this. We have fully custom bearing races out of 60,000 series aluminum, in which we are running tranny bearings, 7/8 long tranny bearings, and we're running those at our rear axle, our bottom bracket, and our front fork. And that is all our metalwork. So once we had all our metalwork finished, we were ready to start construction and assembly. So Christy will take that away.
All right, so first we started off with just giant sheets of cardboard. So we had to do some laminating. And so for some of you who don't know what laminating is you have this giant sheet of cardboard and you put type on wood glue over it, you spread it across that, and then you put another piece of cardboard on. And then we repeated this process until we had the desired thickness. Then we put cinder blocks on top of it in order to compress the glue, and we just left that there to dry. After it was all dry, we put full-scale drawings, blueprints on top of it, and then we traced it out. And so after we had traced it all out, we cut it out using the various tools. Then once everything was cut out, we sanded it and kind of rounded the bits off, and then we dry assembled it, just to make sure that everything fit properly, and if we needed to shrink things down, we could. And so, next slide. And so after everything was dry fit, we put everything together. We used Gorilla Glue to attach our metalwork to the cardboard, and it's stronger. And then we used a two-step process. We first assembled the rear triangle, which is the rear wheel and the frame. And then the second step was we put together the fork, and the front suspension fork. We put tubes together with an air bladder. And then everything was all done, we compressed it, or we put it onto the frame. We completely assembled it with Gorilla Glue. Next. And then once everything was done, we added some finishing touches. In order to reduce metal weight, we decided to make our own pedals. And we used screws for traction. And then after all that, we have our bike. Huzzah, it's Brutus. And none of this would have been possible without the help from our sponsors. Sonico gave us cardboard, GHY bikes, gave us the chain, a bunch of other stuff. Hydro Pack gave us the air bladders for the front fork, and then Psychotherapy gave us the tubes. And so in conclusion, we started off the thing with what is green. Not only is it color or environmental activity, but now we can define it as Brutus. Brutus is green because not only of his eyes, but because of what he's made out of. He's made of recycled cardboard.